This is the solution to problem 5.14 in Munson's book. This problem is an application of the conservation of mass and the continuity equation. It's about a jet engine where inflow rate, mass flow rate is given, and also it's given at what rate the fuel is entering into the jet. The question is, what is the density of the exhaust gases that are coming out of this jet engine? So the first step in this problem is to identify the control volume. So in this case, we use dotted line to identify the control volume of this problem, which includes all the engine, the jet engine plus the fuel intake. Okay. And in case of the surface area, we have the surface area, the cross-sectional surface area of the inlet of the fuel that is contributing, and then the surface area through which the air is entering, and the surface area through which the exhaust is happening. And we can write the equation, we call this the air intake as section 1, fuel intake as section 2, and the exhaust gases outlet as section 3. And using the conservation of mass or continuity principle, we can write that the mass flow rate at section 1 plus mass flow rate at section 2 must be equal to mass flow rate at section 3. Now the problem provides information of the mass inflow rate, which is 65 pounds mass per second. Now remember that 1 slug is equal to 32.2 pounds mass. This is the English engineering system units. Of course, in this case, the answer is required in pound mass per second, so we can keep the same units, but in general, we can always go into slugs and solve the problem in the using the units of mass as slugs. The fuel intake also is given. It's given to be 0.60 pounds mass per second. The velocity at which the fuel is exiting is given to be 1500 feet per second, and the cross-sectional area of the exhaust is 3.5 square feet. Okay, so we can write this equation as we can plug in some of these values. 65 plus 0.6 must be equal to M3 dot, which can be written as the density of the exiting fluid times the velocity of the exiting fluid times the area of the exiting fluid. So the quantity that we're trying to find out is rho 3, the density of the exhaust gases. So we can write this as 65 plus 0.6 divided by 1500 times 3.5. And the answer to this problem would be 0.0125 pounds mass per